All right. So tonight I want to talk about usage of speech-to-text in Meteor applications. And so speech-to-text has been around for decades. And the problem is that most solutions are not very great. They can't really transcribe complete texts that you read out or that you dictate to an app. And I remember trying out some of the early products that did speech to text. I think it was in the late 90s, and they were just horrible. So the detection rate was less than average, and there was almost no tolerance for error. And even these days, you don't see too many apps out there which actually have voice recognition or respond to voice commands. You maybe see it in cars where it's very, very limited set of instructions, where usually it's just listening for a couple of keywords. And if you say turn the radio on, it will basically just capture radio and on and know what you want to do, which is a lot easier than transcribing an entire sentence or even an entire paragraph. And so the problem with speech-to-text is it's actually a very, very hard problem. So first of all, most solutions that you see there, out there that are good in transcribing audio into text are service-based, and that's simply because language, natural language, is so complex that it requires a lot of computational power, and running voice recognition just purely on your phone would first of all consume a considerable amount of memory, not just the runtime memory, but also the storage space for storing the entire model of a language. And then it would only support one language. So ideally you have a service-based solution where you have more capacities in terms of computation and also in terms of storage capacities. And secondly, it's very error prone. So basically it depends on the language. So usually the services that are out there, they only support a limited set of languages. I think IBM Watson Speech-to-Text currently supports about 10 languages. Google, with their new cloud platform, they're working on a speech API, which I think has been released in its alpha state. They are covering about 80 languages. And but even within a language, you can have different accents. And I mean, even me talking, it's not really American English or British English. No, it's Australian English with a German accent. And that makes an already hard problem even harder. Also, the speed at which I speak is important. So if I talk too quickly, it gets harder to separate the words from each other and figure out when one sentence ends and the next one starts. And last but not least, but I think that's actually the most important one, is the context, where the question is whether the weather will be good. So I said weather twice, but I meant two different words. You all know what it means because you can understand the context of what I'm trying to say, and you can figure out which of the one it is. And so that makes it, that also forces you to have a service, because that entire computation it's just too expensive to do it on your mobile device, for instance. Then you have a very, usually you have a domain-specific vocabulary. So when I was playing around with the demo that I prepared for tonight, there was a couple of sentences that I tried out, and especially when I put some technical terms in there, like today I said something about the console, and it was actually thinking I said council, because that's a more commonly used word in general language. But you have other domains like finance, healthcare, law, and other sciences like physics or chemistry, where you have completely different and customized vocabulary, sometimes even slang, like cloudifying something. And that makes it even harder, and the spectrum gets bigger, which also means that it's harder to differentiate between different words. And last but not least, and I think that's one of the main reasons also why we don't see more solutions out there, is that it's technically very difficult. So first of all, I don't know who of you has ever tried to access the microphone via a web application. It's not that easy, and it's also not very robust. So the current demo doesn't work with Safari, for instance. I think it works with only Firefox, Chrome, and Internet Explorer. I haven't tried out what happens if you wrap everything into a Cordova app, which probably has difficulties as well. Then you you enable the microphone and you somehow get that to work, and then you get an audio stream. Now that audio stream is not very good of transmitting it over network to a service that can detect what you're actually saying. So the next thing you need to do is convert that stream into a buffer. Buffer, another one of those more technical things that the average web developer doesn't have to deal with too much, which means it's also a little bit harder to understand. I can tell you, looking at the code that I will present tonight, the package that I provided there contains code where I understand maybe half of it. So that makes it very difficult, because usually I don't have to worry about that. There's other stuff that wraps that for me. And last but not least, to transmit continuous audio and constantly receive updates of what I said, it also requires a socket connection. Again, socket connection is a bit more uncommon than the traditional REST API call, which everyone should be familiar with. And socket connection is a different level, and it's more to handle. You have start events, end event, error events, what happens if the connection gets closed, unexpected, and so that makes it a lot more difficult. And the general structure for Watson Speech-to-Text is that you create yourself a Bluemix account. You need one, and it's the same for the Google service. You will need a Google Cloud account, and then you can activate or provision the speech-to-text service. And in Bluemix you get the first 1,000 minutes for free, and afterwards it costs you 2 cents per minute. And it makes sense because there's a lot of computation happening, and that computation costs resources. So it's very hard to offer that as a free service, and even Google doesn't really do that. They do it right now because they are in the alpha phase, and their system is similar like IBM solution based on a cognitive solution, so they're using neural networks for that. And the system learns and gets better the more it gets used. That's why currently they allow free usage, just so they get more users into the system, so the system can learn and improve. But at some point they will say, okay, now it's accurate enough. Now actually you have to pay for it. It actually specifically says so on their website, and so it will end up in the same in a similar way. So you create your Bluemix account, provision the service, then for that service you get credentials, username and a password. And this username and password you then can send to your Meteor server, which then when a client comes in and wants to access the functionality, the speech-to-text functionality, you first have to retrieve an auth token from the service. You do that via the server, and because you don't want to send out a username and password to the client, obviously. You retrieve this auth token, which is valid for a limited amount of time. I haven't completely explored how long it's valid, but it seems to be somehow session-based, and there's probably some timeout after which that token expires. Then you send that auth token to the Meteor client, and then the client can basically activate the microphone, create the WebSocket connection to the service, providing that authentication token to be accepted, and then transform the audio signal into a buffer and send the buffer in chunks through the WebSocket to the service. Then a response comes back, which is basically the transcript and word alternatives. I get to that in a second, how that looks like. And then you can use that to populate a text area with whatever the person has said. And what I try to do is basically wrap this section down here, which I consider to be the technically challenging, into a single package. Currently it's just a private package, so you can't install it via Atmosphere. But you can, I will provide a GitHub URL where you can extract the package and use it in your own app if you want to. Yeah, so just to quickly get to the point how that service actually returns a response to you as you talk. So imagine I already made a socket connection and I activated the microphone, and then I start saying, my name is Peter, for instance. And so the first word is my, and it comes back as a transcript, my. So very easy word to discover, and it, from the data that I got, it actually has 100% confidence in that I said my. Then I say name, back comes my name, my name is, that's all very easy to detect. Now, then I say Peter, and the first time I tried it, actually something else came back, but technically this is what I would expect. And so there is after you complete a sentence, it can detect that because there's a pause or hesitation, or even just by grammar, it detects, okay, your sentence is finished now. And then it comes back with a complete transcript, where it basically offers you multiple alternatives of what I said. So it comes back with 83% confidence that I said my name is Peter. But there are alternatives there, which could be my name is ER, doesn't make much sense. But it could also be my name is Pete R. Now, grammatically it doesn't make much sense, which is why it is not ranked as high. The confidence is not as high. And then I also have insight into the word alternatives, where I basically get an array in return, and the array contains the words that are said in order, and there are alternatives for the last one, where we see it was only 33% confident that I said Peter, and the next, but I could have said people as well. It said 22% confident that you did so. And yeah, so you have a little bit of control over which transcript you pick, and especially if you're in a specific domain, you might want to prefer certain words to others. You might exclude certain words that in your context never make any sense or not used that often to even improve the accuracy of the transcript here. But now let's get to a demo. So I provided a GitHub repository, and I will share the link in the meetup comments as well. And that's basically how it looks like, but app. And so this is basically how it looks like. And when I open the website, it calls the Meteor method and retrieves the authentication token from the API. And so I already have the token here in my client, which means my client is now ready to connect. It hasn't expired, I just retrieved a new one. And now when I click the button for record, it will create the socket connection, activate the microphone. I already gave the browser permission to do so. And then I can start talking. So let's see if it can detect my German accent. Yeah. Well, so the beginning of the sentence wasn't that great. There's a little bit of inaccuracy in there, but it basically gets what I want. And if you look at the console, I'm printing out all the objects that come back from the API. Those are basically the message objects where, for instance, this one says, gives me a couple of alternatives where it discovered this end here. No. So that, I mean, that right now, with my example, doesn't make too much sense, but it basically gives you a set of alternatives and a couple of word alternatives where here there are the, and other alternatives. But they all have a confidence of how likely it is that I actually said a certain word. So quickly looking at the code, on the server side, we have an NPM package, this Watson Developer Cloud, which offers you a client to do the authorization and retrieval of the auth token. It wraps everything. And all you need is a config object, which provides the endpoint, and a username and password, which here I'm passing in via the server environment. Then you create the authentication service and provide a method that returns you the auth token by calling that service with the provided config. And yeah, the result is basically that token that you could see in the browser. On the client side, when I render the template, I retrieve the auth token by calling the method and store it with the template. And then I have some display-related function which basically populate a text area with my current transcript concatenated with the current sentence. So it always works sentence-based. If you dictate 5 sentences or so, they come in chunks. And after you finish the first sentence and you start the next one, the transcript that is returned by the service only captures the current sentence. So you need to store the previous sentences, and that's what this transcript is for. And the reactive variables obviously ensure that the display is updated, as you could see as you speak. Now, this is the important piece, and this is the part that, so there's a Node.js SDK provided by IBM to use this service, but the problem is it is a complete application with a they have a view layer which you have to deal with. They have a data model which you have to deal with. And I try to strip out all of that and just keep the essence of microphone, socket, and handling that. And that's basically what you see over here, where the contents of the package has a handle microphone file, microphone object, and a socket file which handles the socket connection. And all I need to do when I click the record button is I create myself a new instance of a microphone. I don't have to pass anything in there. That's all wrapped within the package specifically for the purpose of transforming the audio signal into the buffer that is finally sent through the socket. And then I have this handle microphone method which will basically initiate a socket connection and start streaming. Once that happens, I enable the record method of the microphone, and that's what you saw earlier when I demonstrated it. And finally, when you click the button again, in this case, I'm currently recording, I just execute the stop method on the microphone that will close the socket connection and stop the recording. And oh yeah, so when you invoke the handle microphone method, you will basically provide the auth token, which is used to authenticate yourself. Then this is the model here. In this case, I've chosen EN-UK. There's a broadband model and a narrowband model. And as far as I understand it, the narrowband models are more domain-specific, where you have to specify which domain you're working on, where the broadband models are more generic language. And you're also passing in the microphone, obviously, because that needs to be handled. And then we have this callback here, which is the callback that is invoked whenever a new transcript object or message comes in via the WebSocket. And I finally define this here, this on message function. And this is the message that you saw where it was printing out the objects on the console. And I extract the information. I make sure that sentences start with capital letters. I make sure that there are dots at the end of each sentence. And then each message can also contain a final flag. And the final flag only is set when it recognizes, okay, there's the end of a sentence. And that's when I basically append the current sentence to the transcript and reset the current sentence. And then the next sentence can begin. I get new messages which I process in the same way. Yeah. So that basically makes it relatively easy to use from my perspective. And we had a couple of, over the last year, I developed a couple of business applications. And I kid you not, in every single project, there was at least one of the stakeholders who said, oh, can we please get speech-to-text for this input field where I leave my meeting notes or whatever. The idea of you have a meeting and after the meeting, you're sitting in your car, you're driving home. And while you're doing so, you have your mobile app open, you just click record and dictate a summary of the meeting. That's kind of the use case, I think, what most of the stakeholders that asked for it were thinking about. And I think it's a valid one. It hasn't been around too much. It's not used in many applications because of the reasons that I mentioned. It's hard to implement and the detection is not that great. But with the cognitive systems, the detection will get better. And I find I'm now more inclined to use speech-to-text because I've got some easy mechanism that wraps everything and allows me to implement it quickly into any app. Yeah, and that is all, I think. Any questions? Yes?
Sorry to say this, but when you spend time at IBM on the TV screens, they've got advertising about how great Watson is, and it talks to somebody and it pauses for a moment, and then it comes back with some profound insight into how they can do something better in teaching and stuff. What you've shown us, and what you've done is great, I'm not criticising that, but they suggest that Watson is something fantastic. It's this AI platform that will really do wonderful things, and it will think about what you've said and actually then give you a real insight, whereas what you're saying here is that the basic Watson speech-to-text is quite primitive, and it comes back with a bunch of choices, and really what you need then is the brain that they advertise to say, well, I think his name is Peter. that makes sense, right? And that's what's missing in this.
So when it comes to that, from what I understand is that I think even inside a session, the longer you talk, the more accurate it gets, from what I understand. I don't want to promise too much there. What you're talking about is kind of seeing the hidden connections and really getting what people are on about. That basically comes down, so the stuff that you were talking about where you just tell Watson something and then a couple of seconds later it comes back with some insight. That is based mostly on written text. So there was a demo I've seen that was from Under Armour in the US, where they had this customer service portal, which they showed in a demo how an ex-Marine was talking to the system. It was like, oh, where should I live? Which city is good for my interests and all that stuff. And Watson was just asking a couple of questions, which were programmed into the system. The user answered those questions, and then all that information in written form goes into Watson, and then Watson analyzes all the data that it has in the background, which could be millions and millions of documents and articles, news and unstructured and structured data, and finds yourself, okay, people in your situation usually live in this city and they're very happy there. If they live in that city, they are not happy, and that's what it uses to make up a mind. And see, it doesn't work as well with speech-to-text, and speech-to-text is one component of Watson. So it's using the same platform, but it doesn't use the entire brain of Watson, but just a very specialized narrow AI, which basically is focused on detecting audio and splitting up into words, and you have to even specify the language. Why can't it detect it automatically? Now, that question is answered because it can detect the language. There are other services where you can just send a text, and then it tells you, okay, this text is in English, this text is in German, this text is in French. It can figure that out, but only if you write it down. Now, there's still a little bit of a gap, but I think over time that will probably get filled as well. And as I said, those systems are learning, they get better over time. And the speech-to-text service, I think, has been around for maybe a year or 1.5 years or so, and that's not a long time to learn. So give it a year or two and it will get a lot better. And that's the same principle that Google follows these days. They say, come on, guys, please use it, because only if you use it, we actually get better. So, yeah, there is an option to give feedback. So, for instance, I don't know exactly how that works, but you can opt in and opt out of a feedback mechanism. And I think what it basically does is just storing the transcribed audio, and then other natural language processing tools and mechanisms will analyze the text, see what makes sense, what doesn't make sense, correlate that with the recorded audio that was used to create those texts, and that's how they get more confidence in and detect more variations in language and are able to detect it correctly.
Yeah, look, it's not a simple problem.
Yeah, speech recognition is hard, but it needs to be clear that this is only one aspect, and once you have transcribed it, the rest of Watson can do what you said, so it can give you that insight.
But I guess the problem is if it's transcribed it wrongly, then
you will get the wrong answer. Yeah, that's true. Yeah, and that's why I said you need to have a little bit of control over the transcriptions that come back, and look at the word alternatives, and maybe. So after the end of a sentence, you get a couple of potential transcripts. And then you can use the word alternatives to figure out which one of those are the most suitable for your use case. But that requires a little bit of application logic. Yeah.
I'm just thinking if you thought about an integration with the I-18N package.
With what?
The internationalization package.
Oh, okay.
But you could essentially do, you could speak to it in English and have it render out in German or something.
You mean translation? Oh, yeah, but that's just a concatenation. That's actually an interesting use case, I have to say. Yeah.
That's essentially, Skype is like all about that.
You mean that'll help with the German accent?
And even better, you can record it in English, then it gets translated into German, and then you use text-to-speech to speak it out to the other user. So yeah, it could work. Yeah. But it's just you can take those chunks and handle them individually. You don't have to integrate everything in one. So you have your audio detection outcome, some text. Then you use that text and translate it, and then you use the translated text to do something else with it. So yeah, that's
Check out
definitely possible.
Google Translate app.
Yeah, it's pretty good. It's like, I don't know if you can
That depends if there's a good reason why we prefer to use IBM Watson Speech-to-Text and not Google Speech-to-Text. It's mostly because of the intellectual property and that you might provide by speaking. So say you have a customer engagement and you want to track some meeting notes and you're using speech-to-text for that. You don't want to tell Google everything about your meeting. I mean, I don't think that they will abuse that information and kind of try to extract information for them, but who guarantees you that? Yeah, at least with using basically our own software, we can be sure that it won't be abused and we won't have any advantages for it. And legally, it's okay as well, where there's no conflict. All right, then. Thanks for listening.
Thank you.
Next talk next month.